So one last lesson on rational numbers, and that is on what is called prime factorization. This is a little different. It's kind of a lesson on its own. It doesn't go with fractions. It doesn't go with decimals. So that's why it kind of falls in a little section by itself. Okay. So first of all, with prime factorization, you see a number there, prime, that goes along with prime numbers. Okay. So 3 terms I want you to get down. Pause the video, prime number, exponent, and prime factorization. Go ahead and get those down. So as you have heard, remember prime number is a number that only has 1 in itself as factor. So think of a few examples of prime numbers. There would be 2, 3, 5, 7, 11, 13, 19. Those are all prime numbers. You can only divide them by 1 in themselves. The opposite of a prime number, remember, is a composite number. That means it's not prime. An exponent, it is a small number written at the top of a base number. So if we had something like 2 to the 4th, 2 is the base number, and then 4 is the exponent. And remember, this exponent tells us how many times to multiply that number. 2 to the 4th would be 2 4 times, and you multiply them all together. 2 times 2 times 2 times 2. So that's an exponent. We're going to be using those. Prime factorization. That is where every number has a prime factorization, which means you can write it as the product of primes. Remember, product means multiplied. So we're going to be using prime numbers and exponents to rewrite any number that we can. So first thing I want us to do is we're going to be doing something like this. So 10 times 10, rewriting this with exponents, would be 10 squared, 10 to the 2nd power. 10 to the 2nd power is 100. Okay, 7 times 7 times 7 times 7. That would be 7 to the 4th power. And then 2 would be to what power on this last one? It would be 2 to the 6th power. 2 to the 6th power. And that would get you 64. 2 times 2 times 2 times 2 times 2 times 2. Okay, so make sure you understand that. And now let's look at prime factorization. So when writing the prime factorization, we are going to use what is called a factor tree. A factor tree is all about multiplication. And you know how a tree, its branches kind of go out further and further the higher up you go? A factor tree is like a tree flipped upside down. It's got a very top, it's like a Christmas tree. The top, and then it kind of comes out as you go down. So we're going to write this number, 72, at the top of our factor tree. 72 is not a prime number. So that means we're going to have 2 branches coming out from it. Not from the 7, but from the 72. So the question is, what 2 numbers multiply to get you 72? Now, there are more than one correct answer. As long as you do this the right way, it doesn't matter which 2 numbers you use. You're always going to get the same answer at the end. So 9 and 8 were the first 2 that came to mind. Okay, so 9 times 8 gets us 72. 9 is not a prime number. So we're going to put 2 branches under 9. Let's just focus on that. 9 is 3 times 3. Now 3 is a prime number. So what we want to do is box in prime numbers. It's going to come in handy here in a second. So put a box around the prime numbers. Now that we've taken care of this, we can't put any more branches because they're all boxed in. Once you've got a number boxed in, you can't put branches under it. So we're going to move over to 8. 8 is not a prime number. 8 can be 4 times 2. Now 4 is not a prime number. So let's come down here. 4 is 2 times 2. 2 is a prime number. So we box that in. Come back up to the top. And 2 is also a prime number there. You are only done with your factor tree when you cannot make any more branches. So notice every number at the very bottom is boxed in, which means it's prime, which means we can't go any further. So the next thing I'm going to do is I'm going to multiply the boxed in numbers. So I'm going to do this. 72 equals, and usually you go in order from least to greatest. 2 times 2 times 2 times 3 times 3. So I've got 3 2s and 2 3s. The last thing that you have to do, and you must do this last step, is rewrite this using exponents. 2 would be to the third power, because there are 3 2s, times 3 to the second power. And this is my prime factorization. I have rewritten 72 as the product or the multiplication answer of prime numbers, 2 and 3. The exponents don't have to be prime numbers, but the base numbers, 2 and 3, they have to be. And just to check to make sure, 2 to the third power, 2 times 2 times 2 is 8. And 3 to the second power, 3 times 3 is 9. 8 times 9 gets us 72. Okay? Let's look at another one together. The prime factorization of 32. So 32 is going to be at the top. Okay? 32, there's a lot of different numbers you can multiply 32 by. Let's go 16 times 2. Well, 16 is not a prime number. Okay, so I can keep going, make 2 different branches. 16 is 8 times 2. 8 is not a prime number, so 8 is 4 times 2. And then 4 is 2 times 2. So 2 is a prime number, box that in. Come back up here. This 2 is a prime number, can't go any further. This 2 is a prime number. This 2 is a prime number. So all the 2's are boxed in. So notice I have 32 equals 2 times 2 times 2 times 2 times 2. So how would I rewrite that using exponents? 32 equals 2 to the 5th power. And that's it. Because there's no other numbers that are prime in 32 other than just the 2. Okay, let's look at one more together. Let's look at the prime factorization of 98. 98 is not a prime number because it's an even number. Even numbers can all be divided by 2. So 98 divided by 2 would be 49. So I've got 49 and 2. I'll go ahead and box in this 2 to tell me I'm finished with it. 49 is not prime, though, because 49, remember, is 7 times 7. Now, is 7 a prime number? Yes, it is. So you would box in the 7. Now, we've taken care of everything. We don't need to go any further than that. So 98 equals 2 times 7 times 7. And rewrite that with exponents. 98 equals 2 times 7 squared, or 7 to the second power. One thing that you can do is you can write this as 2 to the first power. If there is just one number, you can write that with a 1 as your exponent. That is not incorrect. But you are always going to, if the exponent is 1, you will never see it written there. You'll just see it by itself. So 2 to the first power is the same thing as just 2. Okay, and the last one is the prime factorization of 120. You all pause the video and do that one on your own. Okay, so this factor tree is going to look different for many of you because you probably had different numbers. So I'm going to show you one example, and I'll show you another one as well, but there's a lot of different numbers you can multiply to get 120. The first one I thought of was 12 times 10. Neither of those are prime, so I'm going to just focus on 12. 12 is 6 times 2. 2 is a prime number. As soon as you write down a prime number, put a box around it. I would suggest doing that. You could have done 4 and 3. It'd be the same thing. Okay, 6 is 3 times 2. Well, both of those are prime numbers. So we are finished with this left side. Now let's go look at 10. 10 is 5 times 2. And both of those are prime numbers as well. So I've got all my factor tree finished. Boxes at the end of everything. 120 would be 2 times 2 times 2 times 3 times 5. So rewrite that using exponents. And I'm going to get 2 to the 3rd power times 3 times 5. What if you would use 2 different numbers? Let's say you used, for 120, you could use 60 times 2, 20 times 6, 15 times 8, 40 times 3, 30 times 4, 12 times 10, a lot of different numbers. If I had done 60 and 2, I would get this. Let's see, 10 times 6 here. 10 would be 5 and 2. And then 6 would be 3 and 2. Notice what I have. I have 3 2's boxed in, 2 to the 3rd power, times 3 times 5. That's the same thing. So that goes to show you, as long as you multiply correctly and use your factor tree correctly, you should get the same answer no matter what numbers you use, as long as they still are correctly multiplied. So use that factor tree, get the prime factorization, write it with exponents. So that is prime factorization. You all go ahead and work on those questions in your books. And hopefully you got this down.